Thanks, everybody. My name is Rafael Cárdenas. I'm a staff software engineer at Hiro, and I've been working at Hiro for around 2 years. I'm a member of the API team. It's the team where we build, obviously, the Stacks API, as well as other APIs like the Ordinals API, Token Metadata API, and some others that we have in the pipeline. I'm also a core contributor to the Stacks network and the Stacks governance process via the SIP process. And today, I'm going to talk about how we prepared the Stacks API for the upcoming Nakamoto release on the Stacks network. So in this talk, first, I'm going to introduce the Stacks API for those of you that might not be familiar with it. Just give a brief overview of what it is, what it does, and its role on the Stacks ecosystem. And then I'm going to go over 3 different time periods of the API's existence and how we actually prepared for each of them depending on the circumstances of the Stacks chain and the usage and all the details that I'm going to dive into. So starting with the Stacks API, the role that this API plays in the Stacks ecosystem is actually very important because it is a product that gives you a JSON API that you can use to consume all of the different events that happen on the Stacks blockchain. You can see all the history of the past. You can see blocks and transactions as they are happening right now as well. It is free. It is open source. We build it at Hiro, of course. It's used by hundreds of applications and developers at this point. It's actually what powers our Stacks Explorer that we also build at Hiro. So, pretty much everybody that uses the Explorer or any of the popular Stacks wallets, they use the Stacks API indirectly. So because of this, it is our most popular API product. It is also used in different exchanges that trade the STX token. They either run it internally or they use our public API. And you can also use it for free today. As I mentioned, it's free and open source. We have guides if you're interested. We have extensive documentation. You can actually request an API key if you're interested in building applications over it. But the basic idea of the API is that, as I mentioned, it gives you the history of the Stacks chain. You can see blocks, transactions, all the smart contracts that exist on chain. You can see information about fungible tokens, non-fungible tokens, the proof of transfer mechanism. Actually, in the next coming versions, we'll expose data about Stacks signers on Nakamoto, SBTC, miner participation, and some other great things that we're working on. So first, talking about the past, I'm going to focus once the Stacks API launched its version 2.0, which was in January of 2021. So to put it in context, in Jan of 2021, Stacks 2.0 hits mainnet. Since it was a new chain, it had relatively low activity, of course, because most of the applications that exist today on Stacks didn't exist back then. Obviously, they were either being built or just starting to get teams together to start building these applications. So because of this, the level of token trading inside of Stacks was also very low. And only a couple of exchanges listed the STX token at this point. So because of this as well, the number of transactions that happened on chain was low, but it obviously started growing over time. So during this period, the amount of traffic that the API served was around 1 million requests per day at the highest levels, which sounds like a lot, but it's not really a lot if you compare it to the numbers that I'm going to give you next for the current usage. And the one important aspect to note is that the Stacks block time was also around 10 minutes as it is today. So roughly 1 Stacks block equals 1 Bitcoin block. And this is important to highlight because this also dictates or dictated back then the priority that we had to set on the API to deal with the traffic and the activity that happened on chain at the time. So our focus in performance of the API during this time was pretty much completely focused on the read performance of the API. So the API internally uses a Postgres database, which obviously requires queries to retrieve information. So we made sure that all of these queries ran smoothly and users were able to get the information that they requested quickly. We also implemented read replication with the help of the DevOps team at Hiro to make sure that our database can handle write and read traffic separately and optimally. And lastly, we also put in place different mechanisms for developers to consume this API in real time, like sockets. We wanted to avoid users to having to poll the API multiple times per minute if they wanted to get real-time information. So this worked pretty well during this time. We also worked on load balancing this API to make sure that if there was ever a period of time where there was a high volume of transactions, we were able to scale our infrastructure accordingly to serve that traffic. And we also did a lot of work for disaster recovery, which meant, in case something went wrong, both on the Stacks nodes or on the API nodes, we were able to recover quickly and successfully to the latest point that we had. And this also included chain event replays and some other aspects that we implemented back then. So during that time, we had a couple of high load events. Two came to mind when I was writing this presentation because they were interesting at the time, mostly focused on NFT collections. So if you recall, 2021 was a year where NFT collections were very, very popular, not only on Stacks, but also on other chains, of course. And for example, the Megapond mint, they minted around 25, if I recall, 2,500 unique NFTs, and then CrashPunks, which minted around 5,000. So during this time in this mint, obviously users wanted to mint and claim their tokens as quick as possible. And this meant a high number of transactions being broadcasted into the network that then ended up on the mempool and that the API had to serve so that users could see how their transaction was doing. Another event we had that was very popular was BNS name registrations. I'm sure you've seen names on the internet that end in .btc. Those names are registered on the Stacks network. And at the time, they were very popular. They still are, but there was a huge rush to get as much names registered as people could. You had the under 10K club, country names, band names, et cetera, a lot of different things. And also you started seeing some clever ways that people started trading these names. So for example, the Gamma marketplace figured out that they could deploy contracts to trade, to hold and then trade these names. So this also put some strain on chain. And but yeah, the API was able to serve all of these events. We were able to work around them, but the basic idea was that this is the highest load events that happened back then. Now, moving to the present, and not right now, but I'm also including 2023 because it was a year that represented a massive shift in activity on the Stacks network. If you recall, during January of 2023 was when ordinals on Bitcoin really started exploding. This in turn brought massive numbers of activity to the Bitcoin chain, but also something interesting happened that a lot of developers and users started talking again about Bitcoin L2 solutions and scaling solutions. So since Stacks is one of these solutions, a lot of new users and developers started paying attention to it, started experimenting with it, creating accounts, new addresses. So we saw a very big spike in activity in the network and also on the API, of course. And around this time, also the Stacks 2.1 to 2.4 versions launched on mainnet. So this also required a lot of on-chain activity. And lastly, some new exchanges came online that started trading STX, some very large exchanges. So obviously this also means more on-chain activity. So today, the numbers we're doing on the API are roughly 15 million requests per day on a normal day. We might do more than that if there are some periods of very high activity. I'm going to give you some examples soon. But the important thing to note is that the Stacks block time is still 10 minutes. So still one Stacks block equals roughly one Bitcoin block. So again, our focus on the API is still on the read side of things to make sure that people can get their information and that the API is not overwhelmed, right? Because we also saw a lot of new API keys being generated. So this means developers are interested in building with this API, so that's good. And this meant that our performance focus on the API really boiled down to two main efforts. The first one being caching, making sure that we are fine-tuned in this regard. So we use a CDN in front of our API, and this work basically meant getting the CDN to resolve as much requests as possible without having to either revalidate the API or revalidate the cache header or forward the call to the API. And it also meant that if a call had to be forwarded to the API, we also put in place some internal caches on the Postgres database to be able to serve information as quickly as possible without having to recalculate or do very high computation. And because of the spike on activity, we also saw very, very large blocks confirmed on the Stacks network. And this meant that the DevOps team had to increase the scalability and elasticity on our environments to deal with these large blocks. To give you an example, I posted this on Twitter recently, that the current record for a Stacks block is one that contains 10,795 transactions, which is obviously many times bigger than the ones that we saw during 21 and 22, which had, when they were big, they were like 300, 400 transactions. So, this is a massive increase, but obviously it means that the network is transmitting that much more data and that the API has to process that much more data when consuming these blocks. So during last year, actually focusing more on Q4 of 2023, we saw a few events happen on Stacks that represented massive spikes in activity. So first, I'm sure you've heard about STX20, which is a standard to define tokens on Stacks, closely resembling BRC20 on ordinals. So this brought a lot of activity. A lot of the degens out there started minting or creating tokens, minting these tokens, and then trading them. So a lot of transactions based on that. We also saw STX Map, which is an effort to bring a bitmap from Bitcoin over ordinals to Stacks. We also saw Sortinals, which is another project that tries to peg in inscriptions on Bitcoin from there to the Stacks network via the use of smart contracts, storing data on chain. And then we also saw a lot of token trading, and this is true also today via applications such as Alex or liquid staking tokens like Stacking DAO. We also saw a lot of uptick in meme tokens like Welsh, like Leo. So, the activity on chain increased dramatically during this time. So in December of last year, when STX20 launched, we saw a massive spike in activity, as I just mentioned. And I shared these graphs on Twitter just to give you an example on how the API dealt with that influx in traffic. So, for example, during the highest peak of the mint, we saw around 12.5 million requests in the span of just a few hours on the API. So obviously this during a 24-hour period was much, much more than the 15 million that we see on a regular day. But the API was able to handle this, very gracefully. We also saw at the peak of the mint around 3.8 million transactions per hour, which is just a massive amount. And what this graph means is that when users broadcast their transactions, they're very eager to know when these transactions get confirmed on the network, right? So they, visit the Explorer and start refreshing so that they can see as soon as it gets confirmed, they start broadcasting new transactions. So this put a lot of strain in the API because obviously we had to serve all of these transaction requests as quickly as possible. But the good news is that the API handled this traffic with 100% availability, which was a massive win for us. What this means in technical terms is that we didn't serve any 503 errors or timeouts during this time. And users were able to get their transaction data reliably and quickly. And we didn't have any downtime, which was, of course, really, really good. But now the interesting part, I think, is how do we prepare for the future? Because if we follow the increase in activity from the past to the present, we can safely assume that in the future, we'll see much more activity on the Stacks chain, right? So I'm going to give you, again, some context in this timeline. So around April, end of April, is when we expect the Stacks 3.0 milestone to hit and be released on mainnet. This is also being called the Nakamoto release. And, you just heard a great talk from Kenny highlighting a lot of the different aspects and improvements that Nakamoto brings to Stacks and how that impacts transactions. So the API has to be able to handle all of these changes gracefully because there is a lot of complexity with dealing with the new mining mechanism and all the new types of transactions. But the most interesting aspect of Nakamoto, the one that's most appealing to a lot of users is the introduction of fast blocks. So as I mentioned before, right now, one Stacks block equals roughly one Bitcoin block. So once Nakamoto is live, we will have many Stacks blocks during one Bitcoin block, right? So this obviously changes the game on the API. So I'm going to start by giving you just a quick overview on what we're doing with Nakamoto readiness, and we'll dive into fast blocks after that. So for Nakamoto, we obviously have to update the API definitions around new transaction types and the new mining mechanism on Nakamoto. Again, you just heard Kenny describe this in great detail. But the basic idea is that the API has to be able to first consume these new transaction types and also expose them via the endpoints that we serve, on blocks and transactions. We have to create new endpoints for assuming that we will have multiple blocks, multiple Stacks blocks per Bitcoin block. And we also have to take care of the tenure changes and how miners participate during these changes. And also, we have to support POX4. So POX stands for Proof of Transfer. Right now, we're at version 3, and we are going to transition to version 4. So the API has to be able to handle this transition gracefully, which means making sure that all the tokens or all the STX tokens that are locked in the previous epoch get unlocked successfully in the transition to the next epoch, and that all of the stacking state is handled correctly. So it's a very, very complex work. It is critical work to make sure that Nakamoto works correctly. And also another key aspect is that since the concept of signers is being introduced into the Stacks network, the API has to know which signers sign which Stacks blocks, right? And it also has to expose this information so that developers and applications and users can know what is going on chain, right? So this, by the way, is a joint effort that we are doing with the Stacks core team, the team that maintains the Stacks core repository. And also it's a joint effort with the Explorer team at Hiro, because obviously all of these new transaction types and the new POX signer support, all of this has to be reflected on the Explorer so that users can access this data in a user-friendly way, right? So again, this is something that we are working very hard towards. But next, fast blocks. So this is, I believe, the where I spent most of my time personally working during this past few months. So what does it mean? As I mentioned a couple minutes ago, miners now produce multiple stacks block per Bitcoin block. One stacks blocks happens every few seconds, so they come very quickly, which obviously means that the API write load will increase substantially. In other words, since we will have blocks every few seconds and those blocks could be very filled or very full of transactions, then the API has to be quick enough to consume those blocks in a reasonable time. And this obviously makes write now a very high priority. Obviously, this doesn't mean that the read side of things is reduced in priority. On the contrary, I think the stakes are just that much higher, and we have to be better on how we consume this information. So the work that we did for dealing with these fast blocks is basically reduced to 3 strategies. The first one, we obviously need to reduce the block gestion time. If you remember, during the past period and present period, since blocks were 10 minutes apart, we were able to afford, some slowness when we received a new block. We could process them in 10 seconds, 20 seconds, even 30 seconds when they were very full, because we made the assumption that that was not as high priority as the read side. However, now that's going to change, of course. We also have to improve caching by a lot, because once every block comes, most of the cache that we have in place gets invalidated, right? Because the state of the chain has now changed. So a lot of balances and a lot of transactions get confirmed, and that means that most of the cache has to be revalidated for users to get accurate information. And lastly, we have to introduce and continue doing spike and stress load testing. And I'm working personally on doing this in an automated way. I'm going to dive into this in a bit. So for blocking just in time, I'm reducing, this is like 2 months worth of work reduced to just 4 sentences. But again, this is roughly the work that was made for this. So first, we removed some of the old materialized views or Postgres cache tables, if I could call them that, that we had in place before, because those were very efficient for read operations, but they were very slow for write operations, so they didn't really work for Nakamoto, so I had to remove them and optimize the caching mechanisms. We also worked on batching a lot of the SQL inserts that we do to the SQL tables, because batching reduces the amount of information that goes back and forth from Node.js into Postgres. We parallelize a lot of the data serialization between Node.js and Postgres again, and we also did a lot of benchmarking and optimization around table indexes on Postgres. So this was, again, a very tedious process, and I have to stress that it's super important that we get this right, because even if the Stacks network is fast and it confirms block quickly, if the API is slow, then the perception of the network being slow is what users will get, via the Explorer and wallet. So we can't do that. So I also recently shared this figure on Twitter. This is a comparison between version 7.7 to 7.8 of the API. So 7.8 was when we shipped the improvements on block time ingestion. And as you can see, the improvement is just massive. Every row that you see on this table is a Stacks block, and every value that you see on those columns is the numbers of milliseconds that the API took to consume each one of those blocks. So as you can see, some of them have like a 95, close to 96% of optimization, which is just crazy. So a block that took 26 seconds to be consumed by the previous API is now consumed in a little over a second, which is, a massive improvement. So yeah, we did a lot of testing for this release, and we are now confident that we are going to be able to handle Nakamoto blocks correctly. So now on to caching. So you remember what I've said about caching and how we use it and what the role of the CDN is here, but we're experimenting with new optimizations for this. So for example, taking short periods of time, like a few seconds, and have the CDN serve requests during those few seconds without even having to revalidate on the API. So we're experimenting with that. We're also working a lot on resisting burst requests. So for example, if there's ever a DDoS attack or a massive spike in traffic, just suddenly that we are able to handle that traffic in the CDN or via load balancing on the API. And we're also doing a lot of improvements on individual e-tags, which means that instead of the cache being revalidated with every new block, we can handle individual cache for individual transactions and accounts so that if they didn't change with the recent block, the CDN doesn't have to revalidate this cache, right? This is a graph of the percentage of transactions of endpoints that we serve via cache versus via the API. And you can see on the left side where it goes down is when a new block is confirmed on the Stacks network, which means that most of our cache gets invalidated, but then it quickly jumps back up to around 60%. So on average, we are serving between 50 and 60% of all of our traffic is served from caching, which is great, but we want to improve this number even more. Finally, load testing. We are doing a lot of request simulation, traffic mirroring, performance benchmarking, and automated tests just to make sure that we are continuously testing every new release that we do, making sure that we are able to handle all the traffic spikes that we could get. So looking further ahead, obviously once Nakamoto launches and everything works great, our work doesn't end there, of course, because Nakamoto means that there can be that much more activity on the chain and that much more users. So we're obviously keeping our vision to the next year and the year after that, because we are obviously expecting traffic to continue to increase. Maybe we do a 10x from here, maybe we do 100x, who knows? So our team and the DevOps team have to be very prepared for this. We're also expecting many more Stacks nodes to come online, which means a lot of network activity is going to increase. We'll be able to see fuller blocks and obviously expand our Explorer capabilities so we can serve better information to our users. And yeah, so that's what we're working towards. And if you're interested in the API, make sure to visit this link, docs.hiro.so/API. We also have extensive quick start guides. We have a YouTube channel with videos, dev guides, and we have other APIs like the Orals API. Make sure to check that out. So thank you. I hope you enjoyed this talk, and see you next time.